So before we dive into solving the recursive problem, let's understand the problem. So in this problem, we're looking at the file system query. The reason why file systems and recursion work so well together is because file systems are fundamentally a recursive data structure. You've probably been dealing with file systems your whole life. I have too. It's pretty much the same as when I was a kid, going back to some of the first computers. And what it is you have a folder out there, and the folder contains files and other folders. So you can think of it as like you're in a room, and your room has stuff in it, and there's doors. And if you go through the door, you end up in another room which has stuff in it and doors. And you can go back to the door you came from, or you can go to the next room. Um, the great thing about file systems is we, generally speaking, don't have doors that lead to rooms we've already been to. Like you can only go forward. So I mean, in theory, in a house you can go, around the corner and go in another door and end up in the same room. But we don't have to worry about that in file systems. At least not the way we're using them um, for this example. But the idea is you have logic that applies when you're in the room, and it doesn't matter what's happening outside of that room. I don't need to know what's going on in the whole building to be able to count the number of pieces of furniture in a room. And if I want to know the number of pieces of furniture in the building, all I have to do is calculate in the room I'm in, and then calculate it for the next room and the next room and next room until I've navigated the whole building, right? So for this problem, we're going to count the number of subdirectories, the number of files, the number of hidden files, the contents of all of a directory. And we're going to use this directory right here, the test directory. So if we look at our test case, which we can, we're actually using the test folder, which is the source files test. We're just starting somewhere in the middle of nowhere. We don't know where it's from. I don't know where you're stored this project on your computer, right? It's there somewhere, but all I need to care about is this project. And so in the test folder itself, we can see there's one file, the test case, and then three directories. And then in this directory, there's two more files. And in this directory, there's a directory and another file. And in that directory, there's nothing. And in this directory, there's a file right there. Now, there's actually is something in this directory. If I actually want to see that, one thing you can always do is you can go right click and go to properties inside of here, and then we go up to the resources, and you click on this little button right here, the location, and it'll take us into the directory. So recursion, source, files, test, B, D, and look, there's .5.txt. There's a hidden folder inside of this directory. There's two ways to make a folder hidden. In Unix-based, Linux-based operating systems, you put a dot in front of the name, and if there's nothing in front of the dot, then it just makes it a hidden directory. And so that'll work on your Mac and your Linux machines. In Windows, there's a property that you set as being hidden, and Java detects that property and that naming convention and makes it hidden. And so we'll come back to that later on. But I wanted to set you up with why this problem fits well into recursion, what it means, what we're going to do. We're going to go solve some of this here in a little bit, but maybe you want to give it a shot. Maybe you want to start looking at it on your own. Let me just briefly show you before we do that a little bit about the Java file structure. So when we have a file start directory, you can see there is a bunch of methods on a file object. Now, a file object is not the contents of the file. It's a representation of the file. Think of it as kind of like a business card. I can't talk to a business card, but I can use that business card to get access to the person I want to talk to. So there's things inside of here such as the absolute path, the canonical path. It's the difference between my name is Tony versus my name is Dr. Tony Lowe and I live in Indiana and I work for this, blah, 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 blah. So it's the short version versus the long version of how you get a hold of a file. So one is the file is file system query. The other one is, C drive slash apps slash CSC blah, blah, blah slash recursion slash source slash file. Yeah, so the full path right there. One of the things we can do inside of here, though, is we can list the contents of a directory or list the files of a directory, either one. We can do strings or files. And so, for example, I can do for file F is in list directories. Um, so this is actually okay. You don't have to. You can use this looping for this part of the recursion. The rest of it shouldn't be using recursion, but this part is okay. And I can say line F, for example, right? And so this tiny little bit of code, which by the way, I didn't run this first. You should run it first. But if you did this tiny code and ran it first, we'll count that. Oops, I ran the wrong thing. I did not run the test case. I ran the previous thing I was running. So I got to go to my file system test and hit run that. But again, run first. That's a good example. But now you can say I ran A, B, C, and file system test. So this is the contents of that directory. There's the three things. There's three directories and a file, and that shows you there. And then again, if I want to say, so some more information, I do f dot is directory or is file or is hidden. I can find out all sorts of stuff from that folder. So I can see which ones are directories and do more from that. So that's all I'm going to do right now. I will come back in the next video and I will show you the recursive side of it. But maybe you can give it a shot and play with it on your own, given this little introductory video on the problem and how Java deals with files.